Sir, you can change the slides. So regarding that outline, so here I'll be talking about the basics of electric vehicles, some battery terminologies. So what are the different types of battery and its parts, how to understand the battery from the data sheets and primary function of BMS, and last battery modeling. Okay, so here I have given two diagrams. So one is the diagram of the vehicle and the another one is the diagram of the BMS, which is actually connected in the electric vehicle. So next slide. So next slide. So this is the slide where you can see the different types of vehicles available in our current Indian market. So the first one is the Hyundai Kona, the second one is the Tata Nexon EV. So the third one is some two-wheelers. So apart from that, you have commercial vehicles. So all this shows that as of now, India has entered into the current trending market of electric vehicle, where you can see large number of vehicles are being brought to the market daily, and the huge number of people are also ready to get those electric vehicles. So we will see one by one. So next slide. So this is the basic diagram of the electric vehicle. So as you can see here, the electric vehicle consists of battery pack, BMS system, a controller, and a transmission line. So all these put together will be contributing to our electric vehicle. So on the right hand side, you can see a diagram. So there you have a battery pack, and in that battery pack, you are having n number of cells connected, and from the battery pack, we are measuring the temperature, current, voltage, and all these are given to BMS. So this is what we are going to talk in our further slides. So next please. Okay, so here comes the main question: how to choose an electric vehicle for our application? So first, the question is for driving range. So this is the advertisement where you might have seen nowadays. So for a single charge, that is a battery pack from 0 to 100% SOC, how much my vehicle can be used or how much kilometer it can run. So this is the advertisement for Hyundai Kona, which was introduced in the year 2019. So there you can see for a single charge, the battery can run about 452 kilometers, and this is certified by ARA. So it will be tested under standard driving conditions. So next is the charging time. So here comes how much time is required for my battery to charge from 0 to 100%. So there are two types of charging. One is the AC charging and another one is the DC charging. Generally, the DC charging is faster when compared with the AC charging. Then charging points. So this is the very big question mark or the upcoming technology. So the people who are interested in research, there you can go to this point, which is called as a charging point. That is, suppose you can decide a route from A to B. So there we need to find how many charging points are available, like our petrol or diesel bunks where we go and fill our petrol or diesel. So similarly, we have to identify in our particular route how many charging points are available. Nowadays, many people are hesitating to buy electric vehicle because of this reason. So if the maximum kilometer itself they can drive only for 200 or 300 kilometers, then they have to charge it once again at a faster rate so that the driving range can be increased. But whereas in the IC engine, if you fill the petrol or diesel in 1 minute or 2 minutes, you can still drive more kilometers better when compared with this battery. So this charging point is a very big problem. So now we can apply some machine learning technique or some artificial intelligence techniques, and like what our Google map is doing, we have to find or we have to develop an algorithm based on our destination point. Our BMS must be able to locate where are the charging points available. Next is the battery capacity. So the capacity is nothing but like a fuel in the fuel gauge. If more fuel is available, more distance we can travel. Similarly, the battery capacity indicates what is the total amount of charge available which can be used for any type of application. So here you can consider the example of our mobile battery. So nowadays we have the mobile battery of around 5000 mAh, but earlier it was around 1100. In Nokia phones you will have around 1000 or 1100. Then it went till recently in the Apple phone you are having around 2500 to 4000 mAh. So as you can see, when the capacity increases, the time for which that battery can be used also increases. So next, what are the different ways to charge my vehicle? How can I charge? So there is only one way, AC, or I can also use DC charging. So in the charging, now they have introduced the concept called regenerative braking. So there what happens is during the vehicle runs, it is automatically, whenever you apply the brake, the power electronics technology has been built in such a way that the battery can be charged while we are applying the braking. So this also increases a battery SOC. Then the most important point is the batteries are safe. So you can find lot of advertisement previously where more number of batteries are getting, or the vehicles are getting burnt while they are parked in their parking. So this is because they are not maintained properly. So most of the batteries that has to be maintained or serviced on time, because as you know, when the batteries are kept open, the internal resistance of the battery gets varied, so which increases the chance of the batteries getting exploded because of the heat generated in the battery. And the last and the most important thing, price. So we in our company, when we go for the market, so where we find that 50 to 60 percentage of the vehicle cost is given by battery. So as of now the battery is contributing around 60 percentage. So if we are able to produce an electric vehicle with a reduced price and without any compromise in this performance metrics, sure that the electric vehicle will pick up in the market. Next slide. So what are the different types of vehicle available? So generally we have two types of vehicle available as of now in the market. So one is the pure electric vehicle or the battery electric vehicle. The second one is the plug-in hybrid electric vehicle, and the third one is the hybrid electric vehicle. So from the name itself, you can understand that battery electric vehicle, which shows that pure EV. As of now in Indian market, pure EVs are highly promoted, but still the cost of the pure battery vehicles are very high. So the pure battery vehicles, they will have a charger. That charger is associated in our home or it is available in any mall. So where that battery has to be charged only at those charging points. So the next one is plug-in hybrid vehicle. So from the name itself, you can understand that this is a hybrid vehicle. So it will have both petrol engine and battery. So based on the requirement of the speed, we have the option to operate by battery alone or by pure IC engine. Or sometimes now they have developed a technology where for in order to meet the required power, both battery and the engine will be supporting. The last one is hybrid electric vehicle. Now this is in the current market, which is sold very high. So the diagram on the right shows that a Toyota Hyryder car. So recently this car consists of this hybrid electric vehicle. So the fundamental difference between plug-in hybrid vehicle and hybrid electric vehicle is the hybrid electric vehicle, we don't have the battery to be connected to a charger, or we are not giving any option to get the batteries to be charged by the charger. Instead the batteries are self-charging, so they work mainly basically by the regenerative braking. So the main idea of using this hybrid electric vehicle is generally in the city side, the vehicle speed will be low. And when you are in the urban or in the little bit in the highway side, the traffic will be lesser when compared with the city side. So there they mainly operate with the IC engine, mainly petrol. And in the city side, they operate in the battery. So this recently, if you have seen this advertisement, this car gives around 28 kilometer per liter, which is very high in this SUV segment. So this is possible only by the help of this battery and the petrol. So next slide, please. So this is the spec of the electric vehicle. So this is the spec of the Nexon vehicle. So if you have not seen any advertisement, so hereafter you try to see like this. So first, what is the motor they are using? So this is the motor which is being used in that particular vehicle. So they are using PMSM motor. So next you have to study what is the kilowatt and torque that can be given by the motor. So generally high torque vehicles and high power vehicles are required by the drivers for making their driving to be enjoying and also for smooth. Then the most important part is what is the battery pack they are using. So here they are using around 45 kilowatt hour. So we need to study how these numbers are arrived. So if time permits, I will try to give a small idea in this. Then the next is the thermal management system. So what is the need for a thermal management system in the electric vehicle? So you have battery in your home, you have battery for your mobile, you have battery for small objects like smartwatch or our headphones what we are using. Everything has battery. But why you have specifically a thermal management system in battery means it is done to improve the life of the battery. So as of now, every company claims at least a period of 5 years or 8 years for their battery. But in order to achieve that 5 years or 8 years, we need a management system with BMS so that the life of the battery can be increased. So now you will have a doubt, sir, what will happen if you don't use this system? So when you don't use the system, automatically our system fails or our battery fails. So when the battery fails, now this is a very big challenge for the suppliers or the manufacturers of that vehicle because 60% is contributed by the battery. So when you have to replace the battery within the specified period of time, their market automatically will get reduced. Okay. So this is how you have to see the advertisement. So the next one, on the right hand side you have to see how much charging time it takes. See, as of now you can see that the regular charging time here it is coming around 17 hours, and below that it is giving around 6 hours, then at last you can see 40 minutes. So what is the fundamental difference between these two is the first one and the second one is almost a AC charger. So there it has been mentioned. So generally AC it takes time because inside the vehicle you have the battery. Generally we know that battery operates by DC. So in the our grid we have the AC, that AC has to be converted to DC. Then with the help of the DC-DC converter, our battery has to be charged. So generally AC charging takes time. But when compared with the DC, directly it has been programmed in such a way that it charges at a faster rate, that DC chargers, because it involves both what I can say electronics plus algorithm. Some software is also incorporated in such a way that the DC fast chargers they can charge at a faster rate. So the biggest drawback is if you have noticed in any of the advertisement that generally they don't allow us or permit us to charge more than twice or thrice in a week by DC charging, because when you go for fast charging automatically the life of the battery begins to reduce. So generally they recommend that either in 1 day or 2 day you go for DC charging, rest of the 5 days you can go for AC charging. So this is the general recommendation given by all the vehicle manufacturers. Then the most important part is the warranty. See here you have seen that the battery pack warranty is either 8 years or 160 kilometers, 60,000 kilometers. This is very complex to create this mathematical calculation. So here comes the market. So whatever technology you have, if your battery is not able to support you for this 8 years, then obviously our battery vehicles are going to be not selling in the market. Okay. So then the next point is driving range, which we have discussed already. So what is the maximum kilometer my vehicle can travel? So next time when you see an advertisement, you try to see this and relate, and you try to find out what are the specs they are giving, what are the different types of motor they are using. So in the initial times, I think they were using induction motors. Now slowly they changed it to PMSM motor. So because of its what I can say the advantages, it is able to meet all their design requirements. So basically, I am not from machines background, but what I understood is now they are able to meet the driving range with a specified battery pack specs within the electric motor and torque configurations. Okay, so next slide. So now we will slowly get into how a battery pack is framed. So generally, the left hand side first image is the types of cell. So as you can see, generally the cells are classified into three types based on the geometry. So the first one is cylindrical cell. As the name itself indicates, it will be cylinder in shape. The second one is pouch cell, and the third one is the prismatic. So all these they developed for meeting their design specifications. So working wise, all the three will be same, but slightly in the safety purpose, one battery will be better than the other because of the shape and the type of material they are using. And now you will have a doubt that, sir, generally then what is the type of battery they will be using? As of now, all the three types of battery has been used in all the types of vehicle. Even now, the Tesla launched a vehicle. I doesn't remember the number, but that they are using this cylindrical cells. Okay, so now you have to understand that the most basic part of the battery is called as the cell. So now you are seeing cell, but a single cell will not be able to give us the energy or the power rating. So in order to meet that, those cells are arranged in series or parallel form, and they are called as the modules. So these cells, when they are arranged in series or in parallel, they form the module, and when these modules are arranged in series, they form the pack. So at last in our vehicle, we will have a battery pack, which is a combination of modules, and in that modules, you will have the cells arranged. So here in this diagram I have shown is taken from a real-time vehicle, where you can see in the bottom there is a battery pack, and the motor is connected directly to the vehicle. Next slide. So this is the diagram which I have taken from the MATLAB. So there you can find that how a battery pack is formed. So initially now cell is there. So from the cell, the cells are arranged in parallel. So from that parallel arrangement, they are forming the module, and then these modules are arranged in series and parallel to form the pack. So as you can see in the x-axis and y-axis, as you can see, when the number of cells increases, the number of energy also increases. So this is the idea behind forming the battery pack. So next slide. So this is what we were discussing. So what is the cell? So this you might all you have learned in your basic physics or in the chemistry in your lower classes. So cell is nothing but the smallest form of the battery. Basically, it consists of electrode separator. So which we will be seeing in the next slide. So as of now, you remember the symbol for battery is you will have one positive electrode and you will have one negative electrode. So next, the second one shows what are the different types of batteries or the cells available. And the third one, like this we have seen in your old Nokia phones. So where the batteries are replaceable, where you can take the battery outside or removable from the battery. So if you note down the battery, you will have a specification like this, 3.7 volt, 1900 mAh. So let us see in the further slide what is the meaning of these things. And below is the battery pack which you are using it in your car, and the same battery might also you are seeing for your UPS. So here also you can see the 12 volt 10 ampere hour. So as of from now onwards, you can understand that whatever battery you see, you will have two parameters. One is the voltage and other one is the capacity. So that voltage is called as a nominal voltage, and that capacity is called as a nominal capacity. So we will see the definition in the next slide. So next slide. So generally battery classification. So how batteries are classified is, so as you all know, chargeable batteries and non-chargeable batteries, or rechargeable batteries and non-rechargeable batteries. So the batteries which we are using in our remote or in our small application in our home, like clocks, all those batteries are non-rechargeable batteries. Whereas in our mobile phone or in our UPS, in our car, they are called as a rechargeable batteries. So what is the fundamental difference is, during the charging, one process happens chemically, and during the discharge, one process happens chemically. So in the rechargeable batteries, we are able to bring back those chemical reactions, so the battery is able to be charged again and again. But whereas in the non-rechargeable batteries, we are not able to bring back that chemistry. So it is not possible for us to recharge. So we will see that in the further slides. Okay. So next slide. So this is the battery spec. So whatever cell we will be using. So this is an example of a lithium ion battery. So here you can see nominal voltage, nominal capacity, upper cutoff voltage, lower cutoff voltage, charging current. So these forms the main electrical parameters. You can also see from any data sheet. Okay. So first we will see the right hand side. You have a lithium ion battery polymer. So what is the nominal voltage? So generally why this nominal voltage is given is at the time of manufacturing any battery, the battery manufacturer is not able to still say that every batteries whatever they manufacture is within the specified range given by them. Sometimes they have plus or minus 1 volt, plus or minus, not beyond that. Very minimum voltage is getting deviated from their given voltage. So to avoid that, generally manufacturers what they do is they form a voltage or they tell a voltage, so that now you can have an idea that from this voltage you can have some voltage lesser, some voltage higher. So here in this battery, as you can see, the lower cutoff voltage is 3 and the higher cutoff voltage is 4.2. So as of now you can understand that this battery can operate between 3 volt to 4.2 volt. But the battery manufacturers, they won't tell both the range 3 to 4.2. Instead they say that it is 3.7 volt. So the same thing for capacity. So capacity also, here we are able to have a capacity of around 5 ampere hour. Okay. So sometimes the batteries, they will be also having a capacity beyond this 5 ampere hour. But here we can ensure that at least we will have a capacity of 5 ampere hour. So the upper cutoff and lower cutoff is the voltage operating range. So generally our cell will be operated between this range. Then the charging current. So I will see what is, I will tell what is C in the further slides. But as of now, you understand that charging current, discharging current, it tells that how much magnitude of current that can be given to the battery safely. So suppose your 1C rate is 2 amps means now you can give a maximum current of 10 amps so that your battery works safely. And similarly, the discharge 50 into 200 amps. So you can give a higher value of current at the time of discharge. So this is specified by the manufacturer. And apart from this, so here you can see one cell where they are given 18650. So here the from the figure itself you can understand that 18 shows the diameter of the cell, and in the 650 the 65 tells what is the height of the battery. So like this, what every manufacturer do is, so in that number what they are giving in the spec sheet itself, from that itself you can identify the cell's dimension or the cell's electrical parameters. Okay. So next slide. So this is the battery. I have given you one more example, A123 battery. So here also similarly you can see what are the what is the cell dimensions. So as you can see, this is a cylindrical cell. So you have the diameter and height. So suppose if you are going for a pouch cell or a prismatic cell, you will have width, you will have the thickness, and you will have length. So like that the dimension changes. So here the every parameter is important because you are having cell weight. So when you form a battery pack, we need to consider the total weight of the battery pack. Otherwise the battery pack will be good, but our vehicle will be unnecessarily loaded. So we need to avoid this. So similarly, what will be the resistance? So here the resistance is given by 6 millivolts. So what happens sometimes if the battery resistance get increased or automatically when this resistance is not 6 milliohms, and if it is higher, sometimes if you are making your battery to be in the standstill condition, or if you are not using, and if the impedance of the battery get increased, it automatically shows that the battery is not suitable for using. So like this, all the parameters which are mentioned here are important. Okay. So in the last 2 points, which is very important, storage temperature and operating temperature. So what will happen if you are not maintaining this temperature? So automatically you are making the battery to be operating in the unsafe condition so that there is a chance of the battery gets exploded. So from the technical specifications, what and all you can come to an idea is you can find what are the battery dimensions, what are the battery capacity, what are the battery safe operating limits, what are the battery operating temperature, and in certain spec sheet they will be also mentioning what are the different safety tests they have performed, like a mechanical test, mechanical, thermal, electrical. So here they will be telling what is the crush test. So if our vehicle get accident, so how much force that can be applied on our battery. So nail penetration is sometimes some object may fall on our vehicle. Sometimes water may fall in our battery. Sometimes our vehicle's battery may get vibrated. So there is a chance that our BMS may fail, and sometimes the battery gets overcharged or over discharged. So on all these conditions, how our battery has to be protected or what will be our battery voltage, everything you can find in the data sheet. So most of the manufacturer they provide. Okay. Next slide, please. So here I have given. Sir, are you able to hear me? Sorry, my net was cut. Sorry, my net was cut. Are you able to hear me now? Okay. Okay. So 1 minute now, shall I try as it is net came and went now? Shall I try through my system 1 minute so that it will be easy for me? Sir, are you able to hear me now? Okay, now I'll change my slides. 1 minute. So now are you able to see my screen and you're able to hear my voice? Okay, now I'll proceed from here. Okay. So this is the lithium ion battery. So so in the lithium ion battery, I have given you the two types. 1 minute, 1 minute. So here you have two types of battery. Why I'm telling two types of batteries? The left hand side is the electrochemical cell, and the right hand side is the lithium ion cell. So what is the fundamental difference between these two? So in the left hand side, you can see that is the general diagram of the electrochemical cell. So where you have negative electrode, positive electrode, separator, electrolyte, and current collector. So generally all the cells will have these five important points. So what are they? They have the negative electrode, positive electrode, separator, electrolyte, and the current collectors. Why I am not using the term cathode and anode is, see, the work of this positive and negative electrode is they need to change the atom into an electron and ion. So at one electrode there will be the formation of the electron, and another side that same electron will be combining with the ion and they will form the model. So during the discharge there will be one positive electrode and one negative electrode. Its purpose is different, and during the charge the same positive will be doing the work of the negative electrode. So in general, if you go for electrochemical cell or those who are good at battery chemistries, generally they will not use the term cathode and anode. So instead they say that they will be calling it as positive electrode and negative electrode. So here what is the chemical process happens is the redox reaction, which is called as the reduction and the oxidation. So reduction is nothing but loss of the electrons, and the oxidation is nothing but gain of the electrons. So one side there will be a loss of electron, and another side there will be a gain of electron. So what happens in the positive electrode? So you will choose a material in such a way that that material, some electrochemical process will happen, and that the electrons and ions will be separated. So similarly in the negative electrode also, electrons and ions will be formed. Now the role of the electrolyte is it allows only one type of materials to travel from negative electrode to positive electrode. So the role of the electrolyte is it allows only the ions to travel from negative to positive. So what is the role of the load, or how the electrons will happen is that electrons will travel through the load. So during the charging, your charger will be the load, and during the discharge, your whatever load, like in terms of battery pack, our vehicle will be our load. So this is what happening in our electrochemical cell. But whereas in the lithium ion cell, what happens is the same electrode structure will be there, but here you are having an option that the small violet color dots, which are called as the lithium ion cell. So those lithium ions, they have the option to travel from negative electrode to positive electrode, or positive electrode to negative electrode, based on the type of the process. So if it is charging, the lithium ions will travel from positive to negative, and if it is discharge, it will travel from negative to positive. But the main difference is here the cells or the electrodes, they will be formed in such a way that you have the option to, the lithium ions will be traveling from both positive to negative electrode, and it is called as intercalation. So in that process, what happens is the structure of the electrode remains same. The structure generally changes. So the electrical properties or the electrode size, everything remains same. Only thing, the lithium ions will be moving like a ball from negative to positive or positive to negative. So this is the fundamental difference between the electrochemical cell and the lithium ion cell. But here what happens is they have both the 5 components, but the only fundamental difference is the lithium ions work by the process called intercalation. So to summarize that, what is the meaning is, in the intercalation, only the lithium ions will be moving between the electrodes, where the electrodes are given electrochemically, they have given the property so that these ions can be shifted. So next, why lithium ion batteries? So as you can see, you have more number of materials. Why we have to use the lithium ion battery? So from the diagram itself, you can understand that. So being a vehicle manufacturer, what you will expect, the size of the vehicle and the weight of the vehicle are more important from a customer point of view. So if you are using a product, that should be less in weight and also small in size. So from the figure, you can understand that the lithium is on, it is shown in the 4th component. So there you can see, based on the energy density, gravimetric energy density, as you can see, the specific energy or the energy density, you can see when it increases, the weight also increases. The energy density decreases, the weight also decreases. So similarly, energy, specific energy. So when the specific energy increases, the size of the material also increases, and when it is reduces, the size will also reduce. So what is the meaning of this? So suppose if you are having a 10 ml of petrol and 10 ml of kerosene, so what will be the energy you have obtained by that 10 ml? So obviously we know that the 10 ml of petrol will be giving higher energy when compared with 10 ml of kerosene. So this is what is given by specific energy. So when you compare this lithium ion with other already available batteries like lead acid, PBA stands for lead acid, or nickel cadmium, nickel zinc, you can find that the batteries, even though they are smaller and lighter, they are not able to give that much energy. So at last our main requirement is the energy should also be higher. So when Containing all these three, the size should be minimum, the weight should be minimum, the energy should be maximum. So we should also have some technology to make all this. So all this are possible only with the help of this lithium. So it is because of that reason we are going for lithium battery. Sir, I think from my side I am not able to change. Can you change next slide? Okay. So nominal voltage and nominal capacity. So this is what I was discussing with you first. So whenever if you open any battery and if you are able to see that, there you can find the nominal voltage and the nominal capacity. So here it is given by voltage and the capacity is given by milliampere hour. So the next comes the C rate. So what is C rate? So C rate tells that if you are going to give a current and that current must be within the safety limits. So that is the first point. The second point, it tells that what is the value of the current you can give with respect to your battery capacity. So in this battery which I have shown in this figure, it is 1900 milliampere hour. So when you convert it to ampere hour, it is just 1.9 ampere hour. So in that, what is the current value you are getting? 1.9 amps. So generally C rate here tells that the safe operating limit is 1.9 amps for this battery. So what is the significance of this? So if you increase the C rate to 2C or 3C, what happens? The quantity of the current gets increased. So it will be 1.9 into 2. It will be 1.9 into 3. So if you increase the current, automatically what happens? The time gets reduced. So when you go for 3.8 amps, automatically the time gets reduced. So you will be able to complete your battery or use your battery in half an hour. Okay. So next thing, the other way. If you are keep on increasing your C rate, what happens? We cannot go beyond a particular range. So in your previous slides where I have shown you that your battery can be discharged up to a maximum of 5C. So what will happen if you increase beyond 5C? So here 5C means it is somewhere around 9.5 amps. So what will happen if you go for 10 amps? Surely there is a chance that your battery gets exploded. Okay. So this is how you have to figure it out C rate. So generally as a thumb rule, you can have that C rate and time is inversely proportional. Okay. So next, energy and power. So these two are the two important questions. So now you can analytically you can study from this figure. So here what I have shown is what is the energy. So the energy is nothing but the total amount of juice or the fuel which is available. So if you have more fuel, more energy is available, so that more work can be done. If you have less fuel, only less energy is available, so less work can be done. And from the in the right hand side, I have given you a cell. So there you can find 3.7 volt, 1900 milliampere hour as the voltage and capacity. Now when you multiply these two, you will get the total energy available. So energy is nothing but voltage into current into time. So here voltage is given by 3.7 and the current is given by 1.9 amps and the time is mentioned in hours. So as a result, you are getting 7.03 watt hours. So next time when you see a battery, you yourself can find this is how the energy is calculated for that cell. Next is the electrical power. So what is the meaning of the power? So sometimes if you are having more energy, from that what you can find is how fast I am able to use this energy, how fast I will be able to do this work. So that tells us what is the power. So from the given figure, what you can understand is, see, as you can see here, the juice which is extracted from this tumbler is controlled by the small straw which is put in the top of the tumbler. So when you increase the area of this straw, you can extract more power. When you decrease the diameter of this straw, the power is also reduced. So this is how it tells that how much power is left in the battery. So this how it is used in the electric vehicles. So generally there are many people who will prefer their vehicle should be very much power. That is, it should be accelerate at a very faster rate. And there are a few people who like their battery or the vehicle should travel for more distance. So that is where the market plays an important role. That's which nowadays we are also calling as sports bike and the difference between the ordinary commercial vehicle. So in the ordinary commercial vehicle, generally the acceleration will be lesser. Similarly, in the electric vehicle, the electrical power will be higher if it is like a sports vehicle or sports EV. But whereas if you are using a commercial vehicle, there the energy of the battery will be higher. But there will be some trade-off. There they also tell that at least a minimum of this much power should be extracted. So that they will mention. Okay. So as of now, if you have any doubt, you can ask now, or shall I get into this battery now? Hello sir, is there any doubt or shall I proceed? Hello? Hello sir? Okay. Okay, then I will proceed. So this is the most important part. So how we are going to design a battery model like or until now we have discussed. So generally battery model is classified or from the literature you can understand is there are three types of model. The first one is the electrochemical model, and the second one is the data driven model, and the third one is the equivalent circuit model. So what is the fundamental difference? So in the electrochemical model, the battery model will be a mathematical model which will have equations, and that equations will be of a higher order differential equation where it will be formed after combining all the electrochemical properties like the electrode's diameter and what is some specific resistivity, something related to chemistry. So when you use that model, it is highly challenging to compute those models with the help of the microcontroller which we are having in the electric vehicle. So generally electrochemical models, they will be used in the research purpose or some minimum applications like standalone applications where we are using it in our what I can say the research purpose. Okay. So next is the data driven model. So in the data driven model, what they do, it is what now they are done in the artificial intelligence and machine learning techniques. So where they do the experimental data and they try to form the mapping between the input and the output. So they use some machine learning techniques like the support vector machine, neural network, and ensemble method. So with that they form the or deep learning technique. So with that they try to form the relation between the input and the output. So now this is a hot topic in the research. But what is the main drawback in the data driven model is, so this model is formed purely based on your experimental data. So if you have a high quality data and high number of data, so that model can be used for your data forming purpose. But instead, if your data itself is little bit impure, your model will also be less accurate. And the last one is the equivalent circuit model. So that is what we will be discussing now. So in the equivalent circuit model, you will replicate the final model which will have all the properties of the battery when it is operated, that is either in the discharge or in the charge. So your final model will be a representative of the battery which will have the battery's properties, and it will be equivalently represented with some components. So here we are going to study about the electrical equivalent circuit model which will have or which the model will be formed with the help of resistors or the inductors, capacitors. Okay. So the right hand side I have given you the process. So the input to our battery is the current and the output will be the terminal voltage. So our model, battery model, will take this current as the input, it will process and it will find the terminal voltage, and I have shown a small red mark that the error should be 0. It shows that the experimental voltage should match with the mathematical equation so that the error should be 0. So this is what our idea is. So on the left hand side I have given you a current called UDDS, so which is called as the driving cycle. So in the driving cycle you will have the speed versus time data which will be converted to current versus voltage, current versus time. And on the right hand side you are having the voltage, so which is the normal terminal voltage, so which will be represented in voltage versus time. So our aim is we will give this current data and we will get the voltage with the help of our model. So this is the idea behind it. So the model which we are using is called as the enhanced self-correcting model. So it requires a series of steps to be followed. The first one is, so generally what we know about our battery. So the battery is generally it is considered as a fixed voltage source. So that is how the modeling is started. So whatever may be the current you give, initially it was thought as it was a constant voltage source, and here OCV represents the open circuit voltage. So this will not be connected to any load. So initially the modeling was started like this. So slowly what they found, so this open circuit voltage was also not constant. So this varies. So initially it was on voltage, then it was some voltage. So then later they found out that this open circuit voltage is depending on state of charge. I will explain in the further slides what is state of charge. So your open circuit voltage will be dependent on your charge. So that is what we see in our mobile phone. If it is 0% state of charge, you will have 3 volt, and if you have 100% SOC, you will have 5 volt. So here the indication is SOC is 0 to 100 means this open circuit voltage is available between 3 volt to 5 volt. So this is what they found out. Then later when they connected to a load, there they found out that there is a difference between the open circuit voltage and the terminal voltage from the battery. So generally if you in our circuit theory we have found out that you have one voltage source, you have one load. So when there is a current flowing through the load, surely there must be some resistance connected between these two. Only if there is a resistance, you will have voltage drop across the load. So this concept they incorporated and they added the term R naught, and it is called as the internal resistance of the battery. So it occurs naturally. There is no any resistance connected to the battery. It happens because of the interconnection of the electrode and the electrolyte, or it is because of the combination of more than one component combined during the process of charging and discharging, or sometimes the internal resistance can also increase based on the temperature. So all this contribute to the resistance R naught. Okay. So then what they have found out is, suppose if you give a current and if you remove the current, what they expect is a dynamic response of the voltage. But in real time, what they experience is there is a sluggish response in the terminal voltage. So the terminal voltage, it takes some time to achieve the steady state. So there is some transient response and some steady state response. So this transient response is modeled by the RC pair. So generally if you refer any electrical paper, this number of RC pairs will be 1 or it will be 2. So this number of RC pairs depends on the battery chemistry. So when the battery chemistry changes, the number of RC pairs also changes. So it is not specific. And the last one is, this is the hysteresis voltage. So hysteresis voltage is nothing but when you charge the battery and when you discharge the battery, they have found out that the voltage does not follow same path. I think here I have given you one diagram. So here you imagine you are having one red color path. Suppose you imagine one blue color path below this. So that shows that during the charging the battery follows one path and during the discharging one path. So it is because of the battery chemistry, what happens is there is some small difference between the charging and discharging path, and that is called the hysteresis. So what is the significance of this hysteresis? So what they have found out experimentally is, so when you give a current, you will have open circuit voltage or the effect of open circuit voltage and the summation of all the resistance connected to it. But they have also found out that there is extra voltage getting added during charging. So similarly, when you are not giving any current, what they have found out is there is some open circuit voltage which is connected with the hysteresis. So what they have found out is whether when you give current or when you don't give a current, always there is an open circuit voltage plus some voltage is associated with our process. So that voltage is modeled as hysteresis. So all this put together will be contributing to our battery, and this is called as the electrical equivalent circuit model. So this is how the model is formed. So generally our model is called as a static model, and it is also called as the dynamic model. So in the static model, you will have only the open circuit voltage, and in the dynamic model, you will have R0, R1, C1, all this. So by the naming convention, what is the main difference? Static means here we are not going to connect any load. In dynamic, we will be connecting the load to the battery and we will be seeing what is happening. So this is the basic idea behind this model, and whatever software which we use in our day-to-day like MATLAB or in ComZone, all those models, the reference is this model. Now even in MATLAB, this QRC model is being used in most of the applications. If you refer to any standard examples given in our battery, it will be commonly from 1 RC to 5 RC, but generally in the literature it is specified that 2 RC models is more than enough. So this is one of the IEEE paper which we have referred during our during my research. So the main idea is, so here you will be giving a current to the battery and you will be giving the current to our model. So that experimental voltage will be compared with our model and there will be a generation of the error. So that error RMSE will be found. So here the summation of error is mean square error will be found out. We can also find RMSE. So that value will be fed to algorithms like conventional algorithms like fmin search or fmin con, and the same can also be done in some optimization technique like genetic algorithm, particle swarm, or many algorithms have come like whale optimization. So the main idea is the model which we are using, that model's parameters has to be tuned in such a way that the error between experimental voltage and the simulated voltage must be 0 or minimum. So this is how the entire process works. Okay. So how the static and dynamic test then we will discuss. So in the static test, first we have to do the experimental testing. So in experimental testing, there is some protocol that will be given by each or generated in by some organization. So that protocol has to be formed. But in our process here, what we are doing is, so here what we are going to do is, here we will be maintaining the battery at a particular temperature for about 2 hours. Then slowly we will discharge the battery from SOC 100 to SOC 0. So at that stage we will measure the test data like current, voltage, charge ampere hour and discharge ampere hour. So from this we are having certain formulas or equations given by some researchers, and from that we can find the static model. So from the static model, what you will be finding is, you will be finding the relationship between the open circuit voltage and the state of charge. So at last you will get a graph like this, and this is the average of both charge and discharge open circuit voltage with respect to SOC. So similarly, in the dynamic model, what you will be doing is, you will be giving a current as the input, and that current is representative of your final drive cycle, and that current, based on that current, values of R0, R1, C1, R2, C2, and etc. All these 4 values will be found. So here also the battery will be kept at certain temperature. It will be normalized, and on our required operating temperature, same thing, you will give the current and you will measure these 4 parameters. So here also you have a equation. So as I was mentioning, so this is the equation. So this is a state space equation. Here Z represents the state of charge, IR represents the current through the resistor, H represents the hysteresis. So as you can see, here you have an exponential of R1 C1, and as this is a 1 RC circuit, here you are using exponential of R1 C1. And if you have more number of RCs, and this number of exponential values will get increased. So similarly here you can see that hysteresis equation, and this hysteresis equation is given by Coulombic efficiency and divided by the capacity. And at last this is our output equation. So the output equation is nothing but open circuit voltage is dependent on SOC and temperature, and this M0 and M is given by the hysteresis, and this R are the resistance. But nowadays what you can see is, in most of the research papers, hysteresis contribution is removed. It is because there is no big accuracy, which is what required by them is found because of this hysteresis. So generally what they do is, they have this open circuit voltage and the effect of this internal resistance R0 and R1 C2 path. So this is how the model is formed. So thus finally what you can do is, so first you have to perform the static test, and from the static test you have to form the SOC OCD data. Then you have to do the dynamic test, and from that you have to form the dynamic model parameters. So these two put together to form the battery terminal voltage. So what is the application of this battery model is, so now at last you can find that what we are going to do with this battery model, you are going to give it to an electric vehicle, and from the electric vehicle you will be able to find, from the electric vehicle you will be able to find how much distance my vehicle can travel. So for that what you need a model of your battery. So if you want a more high fidelity model, you have to develop a high accurate battery model. So here what we do, this is a general description which is called as the core simulation. So the core simulation means where you will have a simulation of the battery, where you will have a simulation of the model for the vehicle. So these two will be put together to meet or to find what is our driving range. So on the left hand side you can see what are the different types of driving profiles which are available. So in order to find the vehicle dynamics, you have first from the driving cycle you have to find the desired speed. From the speed you have to find acceleration, and from the acceleration you have to find the force, and at last you have to find the torque. So for all this, if you refer to some papers, so that they have given some equations. So in this I will not be covering those things. So from the violet color what you can find is, first you will find some desired torque, but you cannot make your power electronics or motor to go for this torque, because achieving this torque is not safety, and achieving this torque is costly, and achieving this torque with the help of power electronics also it is not possible. So what they do, so there they put some limits in the maximum torque or the maximum electrical specifications of the motor. So there they limit the torque. So based on that, force, acceleration, speed are calculated. So in this way the loop is done. So from this torque they find the motor power, required motor power, and from the required motor power the required battery power is calculated, and here comes our battery pack. So from this only we will be able to calculate whether our motor power requirement will be achieved by our battery power, and from that battery power at last we need to verify whether our battery is having that particular SOC to achieve this. So generally what in the vehicle manufacturer they do is they will fix the battery SOC range. It is between 50 to 75 or 75 to 100. So if you have or if you maintain a very minimum SOC operating range window between 50 to 100 or 50 to 80 or 20 to 80. So if you fix this operating range, generally the life of the battery will be higher. And here in this slide in the right hand side I have given you some charts, so which shows that what is our battery power which is being extracted for the given driving cycle. So here US06 represents the driving cycle. So this US06 is nothing but where you can see the number of the traffic is very minimum. So the operator is able to have a very good driving. So the current fluctuations are minimum. So the first diagram shows battery power profile. The second one is the battery current. So this simulation gives us an idea that what is the maximum battery power which our battery needs to give for this driving cycle, and what is the battery current our battery pack has to give for this driving cycle, whether it is between the safe operating region. And you can also see at what is the battery power, maximum operating battery power, or the more battery power our motor and our driving cycle put together it is operating, you can find by the demanded power. Okay, then the last one is speed torque characteristics, which is very important. So here as you can see that as the speed increases the torque also get increased, and here you see both the positive torque and the negative torque, which is used for positive acceleration and negative acceleration. So where you can see plus 200 and minus 200. So as you can see the small number of dots which represents for the entire driving cycle where our speed torque characteristics get intersected. So as you can see that one big black line is above 200 and it goes both on the top and the bottom, which shows that if all our these blue dots are within this range, then it ensures that our design is correct. Our battery, our power electronics, our motor, everything is operating based on our driving cycle. So this gives us a clear picture that whatever design we have made, which is correct. This is very, very important during your final checking of your design. Okay. So this is a diagram for different drive cycles, but with the same motor spec. So as you can see here, NYCC is on newer driving cycle, UDDS is urban dynamometer driving cycle, and US 06 as you have seen here. Then HWY is highway cycle. So every manufacturer, they will test their vehicles with this different types of driving cycles. All these are some benchmark driving cycles. This will be tested. So like this, we also have Indian driving cycles. This is available in online. So if you are interested, you can also download it from the your own country's driving cycle, and you can verify. So nowadays in the IEEE data code, you have the driving cycles of different countries. So that gives us an idea that how our vehicle performs under different driving cycle patterns. So this is a small example of MATLAB which is developed. So at last our core simulation looks like this. So here in the left hand side you have a input. So these are the inputs that are to be given by the user for simulation. So here you have to give what is the wind speed, what is the brake pedal, what is the throttle. These are all related with thermal. So this is the example which I have taken directly from the MATLAB. So similarly, I am not concerned about this because this can be changed. So this is our part. So where you can see a battery. So the battery is connected to a DC to DC converter. So here this is a universal converter where the level of the battery will be increased. So and this is connected to a motor. And the output of the motor is connected to the vehicle. And here this red color or the orange color portion is the thermal part of your battery. So why the thermal is important? So when you give a current, either it is charging current or discharging current, your battery gets heated. So because of that heat, what happens? There is a chance that the internal resistance of the battery gets varied. So the internal resistance varies, automatically it brings the thermal voltage down. So here we need to design a thermal system based on this, the total quantity of heat getting generated in the battery, and that is called as a thermal management system. Okay. So in the right hand side, I have given you a diagram. So where you can see for the given driving cycle, what is the vehicle speed, what is the battery voltage, and what is the temperature that is getting generated in the motor. Okay. So as of now, do you have any doubt? Anybody if you have any doubt, you can ask me. As of now, any doubt is there? Hello? Yes, the ESC model and AI based model. Huh? Okay, okay, I'll explain with this slide. See, actually, the main idea is here you will be giving a current and you will be predicting a terminal voltage. Okay. So here in the battery model, which I have given in this blue color box, will have the enhanced self-correcting model, which are developed by the model which we discussed, or the physics based. It will be purely based on physics based equation. So that equation is fixed. So whatever may be your operating conditions, that equation will not vary. You can give any current and you will predict the terminal voltage. But what we are going to do for artificial intelligence or machine learning based techniques is you have to give the current like shown here, and you have to measure the terminal voltage here, and you have to repeat it for n number of cycles at different operating conditions. Like you have to give the minimum current, you have to give the maximum current, you have to give the minimum current at minimum temperature and maximum temperature, you have to give the maximum current at maximum temperature, so and also the minimum temperature. So like this you have to form the your battery experimental data at different operating conditions. So you will have a huge volume of data. Then you have to separate the features. What is your input, what is your output. So this forming this data itself is a huge voluminous task. But once the task is done, then your model gets easy. Anybody who is not in this electrical background, uh, for example, if they are from the thermal background or if they are from the mechanical background, they can also form this model with the help of this machine learning technique. So that is the advantage of the machine learning. But the drawback is you have to form the model or you have to form the data with n number of data, n number of experimental times you have to do. Okay, are you able to get? Okay. Any other doubt or shall I show one small MATLAB code? Is it okay? Shall I show some code? Okay, okay, okay. See, actually, this is what I was explaining. So this is the code which I studied from the Coursera website. So that they have given a code. So see here you can see that this is the experimental data. It looked like that. First it is kept at 100% SOC, then it discharged for each 10% of SOC. So if possible, I will show you the Excel sheet. See, this is how your experimental data looks like. So see, initially the current, everything is zero. So you are having some particular voltage. So you are having the charge ampere hour and you are having the discharge ampere hour. So after some particular amount of time, see after some particular amount of time, so you are giving some current, negative current. So here negative implies it is discharge current. So here you can see the voltage. So for this particular current, what is the voltage? So what is the amount of charges or the charge ampere hour that is getting removed? So you will have both charge and you will also have discharge. So here you can see at what test time this process has been conducted. So from this you are having some equations which they will share the material through the HOD. So you have to follow those equations and you have to solve. So at last what happens is, see, this is your processing temperature. So for 45 degrees centigrade, I have optimized. So here I am using the, I have checked with the particle swarm and now I am doing with F-min band. It is one of the most conventional optimization technique. So here I have given the range for the hysteresis parameter. It is between 1 to 250. So based on this, I have formed the model. So at last, as you can see, so this is the capacity formed for each operating temperature. So as you can see, this is the value of time constant RC for each temperature. So this is the value of R which is formed by optimization. So I am just giving you the whole crux idea how it will be. So if this can be done MATLAB like that way, if you have the capability to develop the code, or if you have a Simulink, now in the MATLAB in the recent version, you have the option called battery table based. So directly you can use that block. So in that block, you have the option to specify what are the different SOCs. So to give this SOC, you should have this value prior to this. So here only 4 SOCs are given, and here for different temperatures you can give this value. For example, here you have 3 different temperatures. For 3 different temperatures, for this 4 SOCs, you can give the open circuit voltage, you can give the R naught, you can give the capacity. So like this you can feed the values, and as I said, for this battery you are going to give the current as the input and you will get the voltage as the output. So here I will show you one example. So this is one online current. So this is an online version of MATLAB. So this is what I was talking. So here you can see the open circuit voltage dependent on SOC. Here you have the R1 value. Here you have the C1 value. Here you have the R0 value, and this is called as the electrical model. And here you have the thermal model. So inside the thermal model, you have the battery thermal mass and you have the heat flow rate. So here it is mentioning that how the total quantity of heat which is getting generated in the battery that can be connected to this, and this is called as the electrothermal model. This is in the SimScape. So once you run the model, so based on the current values, how the terminal voltage is getting varied, and see here the initial SOC is somewhere around 0.4 and it goes to 1 and it's slowly getting reduced. Here you can see based on the driving cycle, what is the total temperature it is getting generated for that particular current. So here initially why the voltage getting increases, here initially here you are giving a positive current. So when current increases, automatically voltage increases. Then slowly you are trying to give discharge current and slowly charge, discharge and charge. Slowly there is a small change in the SOC. Okay. So this is one way. Like this also you can work. And this is the chart type. So this is the most general type. Anybody, if they are good in MATLAB, they can do. So as I was explaining, you have to form the equation, and the state equation and the output equation has to be formed with the help of the Simulink like this. And if you are able to form the Simulink like this, you can also form the thermal voltage. So here, as you can see, so this is the state equation of the state of charge. Then these are the state equation of the two RC pairs, and this is the Simulink for the output equation which we have discussed. So this is how we have to do. Okay. So next we will, sir, still how much time is left? 10 minutes, huh? 20 minutes. Okay, okay. Oh, okay, okay. So is there any doubt as of now here in MATLAB? Whether I have to run something and show, or is it okay? Or shall I proceed with the BMS? Okay, okay. So next comes the BMS. So as you all know, BMS stands for Battery Management System. So this forms the core of your battery pack. So even though we are able to design a battery pack, at last we need to have a system to verify the working of the battery pack. So BMS is nothing but an embedded system. So what is the embedded system? So when you have a very big system, you will design some smaller system or subsystem. These all will put together and it will help us to attain our final objective. So here our goal is in the battery management system, or with the help of the battery management system, whatever from the driver which is requested, it has to be given by our vehicle. So to carry on this process smoothly, we are in need of large number of components put together. Like you have a battery, you have an inverter, you have a motor. So all these things, you have some sensors, everything will be acting together so that the battery is, the energy is extracted and it will be used in our driving cycle. So as I mentioned in the earlier slide, and the bottom you can see one BMS. So you have two different colors. So first one is the analog and the second one is the digital. So one is used to collect the analog signals and compute that, and another one is used to collect the digital signals. Because certain sensors they give analog, certain sensors they give digital. So it's up to our wish. So this is a real-time BMS. So what are the functions of the BMS? So as I have indicated, 5 important processes it has to do. First one is monitor. Second one, with some interface, it has to communicate and tell what and all it has measured, control. Third one, it has protection. Fourth one is the performance management, and last one is the diagnostic. So what is monitoring? What it is going to monitor? So from the first slide which I have mentioned, So in the cell or from the battery pack, you have to measure large number of data. So you have to measure voltage from each individual cell. You have to measure the current. You have to measure the temperature. So what will happen if any of these three things? Surely there is a chance of battery getting exploded. Then you have some contractors. So these contractors are just to protect our device. So when you are connecting some device, these contractors, what they do, they give the required voltage. Sometimes when more voltage or more current is given, this contactors, if they are not there, it will surely damage our battery. So it will be called as these contactors will be used with the pre-charge circuits where our battery will be used for, or where our battery will be getting protected. Okay. Then there are some ground fault detections and thermal management systems. Those things also has to be monitored. So if any of these things fails, it automatically makes our battery to be exploded. Then interface. So as you give a driving cycle, there will be some estimation range. This much kilometer my vehicle can travel. And what is the communication? You will have a CAN protocol, and from the CAN protocol you can find is there any over voltage or over current detection is there, whether my battery has to be charged. So like that you can get messages. So those communications are also happening with the help of the CAN. Then data recording. So this is the most important part. So nowadays in the IC engines we don't record anything in the vehicle, but in electric vehicle we need to have a data record, because when you analyze that record you can find whether our battery is getting operated sometimes in the non-safety regions. So when this non-safety regions getting added or operating our vehicles in non-safety region will surely make our battery's life getting reduced. So in order to analyze that, we need to form a data recording from our battery pack. And last, reporting. So from all these things, the reports will be generated. So all this is done in the interface. Now in the most of the what I can say, the vehicle, you are having this reporting. It says that last travel, how much distance we have done, last travel, what is the SOC has been done, when is our last charge, when is our 100% SOC, when we have made a very good economy. All these are reports which are generated. So to do that, we should develop some algorithm in the background. The next one is protection. So when you have current, there is a chance that our battery gets overcharged or over discharged. So we need to protect our battery. Our BMS will have a controller which takes up this as their main role, and they detect whether our battery is overcharged or over discharged. This can be found with the help of current value and also with the help of voltage value. Sometimes the temperature will also contribute to this. Suppose if it is getting over discharged, the temperature goes to an abnormal level. So this happens during a short circuit, or sometimes even when you operate your battery at a very high temperature, like suppose they have mentioned your battery should not be operated about plus 45 degree or plus 50 degree. So what happens when you are operating beyond 45 or 50 degree? Naturally your battery gets heated. It is because of the increase in the internal resistance. Similarly, if you are operating your battery at sub-zero temperature, that is minus 10 degree or minus 15 degree, there is a chance that our battery's thermal resistance get increased to a very high rate. So put together, it is mainly used for protection. Then the last one is performance management. So this is something which is done by algorithm. So how you can measure your battery's SOC? So what is the meaning of state? So state shows that something certain variables that change at a very faster rate, and there are some parameters which vary at a slow or very minimum. So the difference between these two is called as state and parameters. So generally parameters changes very slowly, but generally state varies very fastly. So in our mobile, you can have the state of charge. So I forgot to mention what is state of charge. So what is state of charge? It is nothing but the ratio of the currently available charge to the total available charge. So for example, here I have taken one diagram and shown you. So this is a diagram which I have taken from my mobile. So here, as you can see that my battery's SOC indicating is 92%. So my 100% of my battery is 4000 mAh, and now it is showing 92. So it shows that the remaining battery to that is 3680. It shows that 8% of my charge has been completely used. So remaining I have 92% the charge is left. So thus SOC indicates that what is the current charge available to the total number of charge available. So this is what is done by our algorithm. It estimates the ratio. What is the current charge available? Okay. So why we have to estimate this SOC? Because now you have a driving range. So based on the driving range, my algorithm has to estimate that whether I have this particular SOC to travel to that particular range, or my algorithm has to indicate that no, you have to charge at this instant, otherwise your battery will get completely dried out. So similarly, the power limitation. So what is the maximum power which is getting extracted from the battery? Too much power is getting extracted at a very minimum time. The health of the battery will be decreased at a very faster rate. So that limit has been put on what is the maximum amount of power that can be extracted. And the most important thing is battery cell balancing. So what is cell balancing? So you know that a battery pack is formed by cells that are connected together. So when you connect the cells in series or in parallel, or mainly in parallel, the current or the voltage and the capacity should be same. So what happens when the voltage or the capacity is not same? Automatically the battery pack's final voltage and final capacity will be reduced to the cell which is having the lowermost voltage. So the rest of the voltage and capacity being used by this faulted battery, or the battery or the cell which is having the lowermost voltage. So the cell balancing plays a very important role. And the last one is diagnostics. So this is very important. So in the BMS, when this detection fails, your battery pack fails. When your battery pack fails, automatically your vehicle fails. So these are the 5 important things that our BMS must do. So in order to do this, there is an architecture which is being developed. So this you might have studied in your microcontroller, a concept called slave and master. So what is the role? Master will do certain process, slave will do certain process, and they both will communicate with each other that certain inputs will be taken from slave, certain input will be taken from master, and at last our required objective should be completed. So similarly,